Relative sea level rise is directly threatening the future existence of Alexandria, Egypt's coastal community. This is directly attributed to the expansion of seawater and the melting and expansion of ice sheets. The vulnerability of Alexandria stems from its location, as it sits on Egypt's Mediterranean coast with an elevation nearly at sea level. From a global perspective, sea level has risen by about 7 to 8 inches since the Industrial Revolution, with 3 inches of those being since 1993. That said, areas such as Alexandria will continue to be threatened, as future forecasts predict sea level rise in 2100 of about 30 inches if we continue on our current business as usual track. Sea level rise is expected to continue into the future, though the changes will not be the same everywhere. Low-lying areas will be exceptionally vulnerable. As sea levels rise, Alexandria will have to deal with increased tidal floods and an increase in flooding associated with storms. In the future, the community of Alexandria will have to either adapt or relocate. As we move into the future, the rising waters will eventually contribute to erosion and land loss, which is already happening in Alexandria. A loss of beaches will surely impact the tourism industry, of which Alexandria is heavily dependent on. Additionally, local farming will be heavily impacted, as the Nile Delta produces more than half of the produce for the area. Many farms have already adapted to an increase in salinity by adjusting which crops they now grow. Additionally, the local fishing industry will surely suffer as well due to the warming of the water, which will increase the distribution range of certain fishes. As the common theme goes for climate change, there is no easy solution to the problem that Alexandria is facing. The socioeconomic conditions of the area will ultimately prevent the necessary attention and funding in order to properly combat the issue. That said, local farmers will have to continue to adjust the type and variety of crops that they are planting, those that are less prone to increased levels of soil salinity. Ultimately, a retreat from the coastline is likely.